morning friends. Up till now in the previous series we have discussed on the statically determinate beam, specifically the shear force and bending moment diagram. I wish you might have been read at your home and understood the fundamentals how to plot the shear force and bending moment diagram for statically determinate beam, specifically simply supported beam and cantilever beam. Now today we are going ahead for once again solution of the more problems on cantilever beam. Let us revise. The objective of this session is understand the concept of shear force and the bending moment and plot the shear force and bending moment diagram for cantilever beam. Let us revise once again. What is shear force and bending moment? When a beam is loaded by forces or couples, stresses and strains are created throughout the interior of the beam. These internal quantities are referred as shear force and bending moment. And our intention in the today's study is to find out this internal quantity along the length of beam, and then we have to plot that variation along the length of the beam, and it is to be termed as shear force bending moment diagrams. Now shear force is technically defined as the algebraic sum of all the vertical forces acting to the left or right of a cut section along the span of the beam, while bending moment is the algebraic sum of all the moment of the forces to the left or right of the section. This is the typical sign conventions which I am using since from last 4 lectures. For shear force, this is a beam is there. If I will cut a beam over here at this section, then the section left upward or section right downward is treated as positive shear force. This is my sign conventions. You may take the opposite of that also. Now for bending moment, section left clockwise or section right anti-clockwise, this is to be called sagging moment nature. It is to be treated as positive moment or positive bending moment, and vice versa, section left anti-clockwise, section right clockwise, this is to be called named as hogging bending moment, treated as negative moment. As this is the basic sign conventions which I am using throughout my series of SF and BM diagrams. Yes, up till now in the previous case we have stopped by solution of the 4 different problems for a cantilever beam. Today we are solve some more numericals on the cantilever beam, and our intention is to plot shear force diagram and the bending moment diagram. Now this is the problem. This is a given particular beam whose one end is fixed, another end is free, subjected to the external loads. First is the point load 20 kN, 0.5 meter from the fixed end, and the UDL of 30 kN per meter for the length of 1 meter. So this cantilever beam subjected to the combination of load of UDL as well as point load. So now our first step is to find support reaction. Let us revise. The one important point is there, it is not necessary or it is not compulsory to find out the support reactions for a cantilever beam, because if we take a section over here and if we take a right section, right part, then we can easily determine the internal force quantities, that is the shear force and bending moment at a section, because not the support reaction will be encountered on the right part. So it is not necessary to find out the support reaction for a cantilever beam. It is a different issue for a simply supported beam and an overhanging beam, that the first step is to find out the support reaction. But for a cantilever beam, this is not a compulsion for us to find out the support reaction over here. But let us now find out the support reaction by using the conditions of equilibrium. The first sigma h is equal to 0. For the given beam, no horizontal force is acting along the system, so RAH, which is acting over here at A point, is equal to 0. The second equilibrium condition, sigma V is equal to 0. Now, RAV that I have assumed as is upward, and upward sign convention for the reactions for the vertical forces that we have treated as positive. So plus RAV. Now this 20 kilonewton which is acting downward, so minus 20. The another load that is of UDL 30 kilonewton per meter, which is acting for the length of 1 meter. So my here, please bear us, this is the minus sign over here, minus 30 into 1. So this is minus sign over here. So overall VHU RAV is equal to, because if I will read on equal sides, then this 2 goes on the right side, which is equal to 50 kilonewton. Now next, the third, because this is the end, that is the fixed support. At the fixed support there are 3 reactions are there: horizontal reaction, vertical reaction, and a moment. So now my intention is to find out what is the moment generated over here, that is the MA. So for that, the summation of all the forces acting over here we have treated as 0, and assuming MA which is of anti-clockwise nature, so minus MA. Now next, 20 into 0.5, this creates the moment of clockwise nature, so 20 into 0.5, this is the plus sign. Please once again bear this, instead of minus this is plus sign, because this also creates plus. So 30 into 1 into 1 plus 0.5, which is equated with 0. So let us see over here on this tabletop. This is a given beam. This is of 20 kilonewton. (30 kilonewton per meter). Now, this is the assumed sign convention RAV. MA, and this is RAH. This we got it 0. This RAV found out as, because this is of 1 meter, this is of 0.5 meter, this is of 0.5 meter. RAV as 50 kilonewton. Intention is to find out MA, then minus MA as we have assumed as it is of anti-clockwise. You may assume clockwise also, because this is the question of assumption, and if the final sign comes negative, then we have to change the direction of the sign. Then this creates clockwise, then plus 20 into 0.5, this creates also plus 30 into 1 into 0.5 plus 0.5 plus 1/2 is equal to 0, and VHU MA is equal to 55 kilonewton to meter. This positive sign indicated that our assumed sign direction of MA is right. So MA, which is of anti-clockwise nature. Now after finding RAV, after finding MA and RAH, let us draw the shear force diagram, or let us found out what will be the variation of shear force along the length of the beam. The given beam, which is of cantilever, subjected to the point load and the UDL we know the support reaction also. Now, if we take, as we discussed in the previous lecture, that for a cantilever beam we are taking a section from the right side so that lesser number of the force will be taken into the picture, and we will able to find out the variation of shear force as well as the bending moment very easily. So if we take a section over here, section XX, the diagram is like this. (30 kilonewton per meter). This is X. Therefore, shear force at X is equal to 30 into X. Now, be careful over here. This 30 into X is there, which is acting section right downward, and as per this is treated as positive. Means if we take X is equal to 0, means at B junction the shear force is 0, and if we take X is equal to 1, we get SF at 1 is equal to 30. So what we obtain over here, if this is our baseline and all the positive values are shown above the baseline, this is 0 because X is 0, shear force is 0, and here it is of 30. See the equation, linear equations we can join with the help of inclined straight line plus sign. Now, between this point and this point, means if we will give the name A, B, C and D. So between C and D not a single load is acting. So means if we take a section over here, the value of shear force remains unchanged, means whatever the value at D, the same value remains between C and D. Means between two loads, if there is no load, the variation of shear force is given by horizontal straight line. This is remains 30. Next, now this 20. Now see, at this C point, the point load is acting, then shear force variation is given by sudden change at that location. Now question may arise whether I will go downward or whether I will go upward. Now see the things, this 30 into X which is acting section right downward. If I will take a section over here, and in that case this both the loads, this UDL and UEL, this point load, both having the direction of downward. So section right downward treated as positive. So if I will take a section over here, then in that case this 20 will be additive with this, means this will become like this 20. So 30 plus 20 is 50. Between C and A there is not a single load, variation is given by horizontal straight line. So this is our shear force diagram. Visualize carefully. This is the shear force diagram. See the things, UDL variation is given by inclined straight line. Between two loads, not a single load, variation is given by horizontal straight line. At a point load, the variation is given by sudden change. But here this change is additive because both the load having a same nature, that is acting downward section right, hence this is additive. And finally between A and C, no load, horizontal straight line, so we achieve the reaction Ra over here. So this is our shear force diagram, variation of shear force along the length of the beam. Now let us go for the bending moment diagram. So please see over here on this PPT, variation of shear force diagram, the same thing that we have achieved over here on tabletop. Now let us go for bending moment diagram on the tabletop. Now our intention is to plot variation of bending moment along the length of the beam. What is bending moment? Bending moment is algebraic sum of the moments to the left or right of the section. So if let us take a section over here between D and B, section XX, the figure is there with us. The bending moment at XX is equal to 30 into x is the force into x by 2. 30 into x is force multiplied by the perpendicular distance where this force is acting. So now this force is acting over here at the CG and this distance is of x by 2. So we achieve 30 into x by 2. Now question is about the sign conventions, very much important. Definitely this moment is of clockwise. Now don't say only use the word clockwise. Section is very much utmost important. So section right clockwise and section right clockwise creates the hogging moment, and as per our sign conventions the hogging moment will be treated as negative, so minus sign. So even though this moment which is of clockwise nature we are taking as negative, the reason behind is that this is clockwise moment, obviously it is clockwise, but for bending moment the sign convention this clockwise which is of section